Rob, thanks so much for taking the time today.
Oh, thanks for having me.
Well, listen, I'm looking forward to diving into all things protein supplementation and training here today. But before we do that, can you tell listeners a little bit more about yourself and your journey at McMaster?
Yeah, well, glossing over with broad strokes here. I was really interested in sports growing up. Played a lot of competitive sports, hockey, baseball, basketball, soccer, and rugby. Continued in high school sports too, all those plus volleyball. Ended up playing rugby in university. So sports have always been a huge part of my life. Did a kinesiology degree, and during that undergraduate degree, I got very into strength and conditioning and sports performance. So that took me. I did some work in the NCAA at the University of Louisville. Worked with Hockey Canada, a couple of the McMaster teams, as well as an AHL team, the Hamilton Bulldogs at the time. So my plan was always to become a sports scientist of sorts, but rolled into graduate school and absolutely loved it. I am finishing my PhD now with Stuart Phillips and loved it. So I think I've kind of given up the sports science dream for now, but that's the area of research that I'm interested in anyway. And it all kind of comes back to my background and passion for sports.
Yeah, it's impressive stuff, and impressive group over there at McMaster, and looking forward to diving into your terrific research here around resistance exercise training in combination with protein supplementation. Obviously, definitely a common practice, especially in athletes. We see this also in recreational exercisers. Yet, as you point out in your work, large meta-analyses previously in this area have yielded some conflicting results. So again, leading us into your work, can you tell us a little bit more about the rationale for your study and what question you guys were trying to answer?
Yeah, for this one in particular, it was pretty simple. It was just to answer the question of whether protein supplementation works or not. Specifically, during periods of weight training, if you supplement with protein, does it increase or augment your increase in muscle size and muscle strength? And that's what we were after.
Terrific. And can you, in a meta-analysis, you're obviously starting out with a large number of studies. You guys whittled it down to 49 studies that you included. So for any listeners who aren't as familiar, can you talk about, what that process is like and how you ultimately came to the 49 studies you included in this paper?
Yeah, so a meta-analysis is really it's a combination of a bunch of individual studies called randomized control trials. We had 49 that we put in, like you mentioned, at the end, but to get to that number, we started with over 3,000. So what we do there is we do big database searches. So any paper or any book published on the topic of protein supplementation during resistance training, we searched for and we found there was 3,000. Some of them were duplicates. Some of them didn't meet our inclusion criteria, which I can talk about. But we were able to sift down to about 49 that were in healthy people. They were long enough to meet our inclusion criteria, which is 6 weeks. We didn't see a point of including studies that were maybe a week or two long, for example. And that 49 studies included almost 2,000 people. So we tried to do a very comprehensive assessment as we could. But yeah, I started with over 3,000.
Yeah, that's pretty impressive. And after all that analysis, I'm sure everyone's waiting with bated breath here to see what the outcomes were. I'm sure a lot of them have already read the paper. But what did you guys find with respect to protein supplementation and strength?
Yeah, well, it was interesting because, like you said, there have been so many conflicting opinions and some conflicting meta-analyses themselves, tons of conflicting individual studies. So I didn't really know what to expect, but to put it out there, we found that protein supplementation during periods of weight training augments changes in muscle mass and muscle strength. So it was a green light to the protein supplementers anyway. But yeah, that's what we found.
And in terms of that benefit, what kind of degree of benefit are we looking at here? And was there any, differences when we're looking at more of an athletic population versus recreational?
That's a great question. In general, the benefits were very small, and that's an important message that we've tried to get out as well. the benefit you get from weightlifting is probably about 90% of the benefit of the change in muscle size and muscle strength. The benefit you get from protein supplementation on top of that is peanuts in comparison. In fact, it's about 10%. To give you that in a number from the meta-analyses, so the studies lasted for an average of 13 weeks. So lifting weights for 13 weeks with or without protein supplementation augmented changes in fat-free mass, let's say, by about 1 kilo. So you put on 1 kilogram of muscle in 13 weeks. And the group that got protein supplementation on average got an extra 0.3 kilos. And it had a confidence interval with it. So some people will only put on maybe 0.2 pounds to switch it up, for, if that's more familiar, to about maybe 1 pound of benefit from protein supplementation. So I suppose my point is that protein supplementation was effective. It was statistically effective, but I mean, it's largely peanuts in comparison to the actual resistance training.
Yeah, I suppose to the naked eye, it's tougher to be able to tell versus obviously being statistically significant. And Rob, did you guys find in terms of a dose then, in terms of a daily protein dose that was sufficient then to meet these requirements, and above that there was potentially no response?
Yeah, one of the things that we wanted to look at, because there had been other meta-analyses, that look at just older people, just very resistance trained people, or maybe people who are in the hospital. So different populations, a bunch of different things. But so we ran what are called meta-regressions, and meta-regressions allow you to look at the effect of covariates, or in plain English, a meta-regression allows you to look at the effect of things like protein dose or protein source, if it's soy versus whey, et cetera, et cetera. So we did a bunch of those. And what I thought, maybe protein supplementation would be more effective if the participants were given, maybe 40 grams instead of 5 grams. Or maybe it would be more effective if they were given whole foods like eggs or something versus, or eggs or yogurts versus whey or soy protein. And so we looked at a bunch of those things. And to our surprise, none of those things really mattered. And that probably is a consequence of the low efficacy of protein supplementation, period. So the effects you're trying to wring out by comparing whey versus soy, for example, are minimal. Having said that, I think what we're referring to is the biphasic regression that we did. So we looked at daily protein intake, because some studies had people who maybe were getting about 0.8 grams of protein per kilo per day, and maybe supplementation would be more effective in them versus people who were already getting, let's say, 2 grams of protein per kilo per day. So we kind of threw the protein supplementation question out the window for that, and just looked at, can daily protein intake predict the benefits of or the changes in fat-free mass with training? And that was really neat. That number, so the number we came out with is that beyond protein intakes of 1.6 grams of protein per kilo per day, there's no extra benefit of protein supplementation. And that number's been incorporated into the International Olympic Committee, for example, the International Sports Nutrition Association, or what's it called? I think it's called ISSN. And that number's been kicked around a lot. And that was honestly a few of us sitting around a laptop thinking, like, it's so hard to compare all these studies. There are so many factors that might come in. Let's just look at daily protein intake. And I think that's a big takeaway, is that how much protein you get during the day in total is much more worth your time considering than whether or not you take a protein supplement before you go to sleep or something, or after your training.
Yeah, it's a fascinating point, and such an important point, isn't it? That athletes and active people need to be thinking about that daily intake. Are they being consistent and achieving that day after day, versus thinking that simply that protein supplement at the end of their training session, as you mentioned, that sort of 10% is really going to be the make or break, when really that daily intake is really the biggest bucket, isn't it?
That's a great way of putting it. It is the biggest bucket.
And Rob, one of the things that I think people might, there's probably some confusion as well around, at greater than 1.6 grams per kilo per day, is that simply we're not building any more, muscle mass? What's happening to the rest of that protein? Because that's definitely something that gets a lot of confusion on the interwebs around whether it's absorbed or what it might be utilized for. Can you shed a bit of light on that?
Yeah, that could be a thick question. But in general, what you do, so let's say if you just have protein in your diet for ease of explanation, you can take some of those amino acids and you can shunt them and make more glucose. That's possible. But if you're already getting enough carbohydrates and fats and other energy sources, for example, a lot of that protein is going to be cleaved off, and the carbon skeleton can go all sorts of places, including it can be breathed out. The nitrogen you'll pee out because it's toxic. So in general, your body's not using it for muscle growth. And I think that's the whole, at least for the context that we're talking about it, that's why people would consume higher protein diets, is to put on more muscle. And the point is that we're not using that for muscle. We're either using it for fuel if we can't get fuel from elsewhere, or we're getting rid of it.
And that's a really powerful point as well. I mean, obviously myself dealing with basketball players and athletes who tend to be the harder ones to put, size on. And oftentimes protein is that macronutrient that's gotten all the focus in the last sort of decade or two. And everyone's protein focused post-exercise. And obviously what your research is highlighting is that once you've achieved that 1.6 grams per kilo per day, then really you've got to be making sure that you're achieving your total energy needs and carbohydrate needs, don't you, to be able to achieve that if you're looking to add hypertrophy and more lean mass.
Yeah. I mean, I might be biased, but I do think that protein is the most important of the macronutrients. There are essential fatty acids, omega-3 and omega-6s. There are plenty of essential amino acids, but there are no essential carbohydrates. So I do think that if I was working with an athlete population or anyone in particular, weight loss, whatever it is, my focus would be on protein. And I should mention that that 1.6 has a confidence interval with it. Confidence interval is exactly how it sounds. It's 1.6, but it could be a little less or it could be a little more, depending on a number of known and unknown variables. And the upper confidence interval is 2.2. So some groups have recommended 2.2 as the number, because if you get, you're guaranteed to get all the benefits from protein supplementation. So I suppose an asterisk on it, but 1.6 for someone who's 6'5" and maybe, I don't know, like 200, 250, 300 pounds, it could be. That's a lot of protein.
Absolutely. I was going to ask around that general heuristic you tend to hear is the gram per pound, which, as you mentioned, becomes the 2.2 grams per kilogram. And so we see that as sort of the upper end of intake. And, if that's not impacting an athlete's appetite and they're getting enough fuel on board, are there potentially some other benefits there, or is that going to be really depending on the individual?
Yeah, I suppose that's the art of what you do and what many sports scientists do. So I think it's on the individual for that one.
That's terrific. And you talked about, Rob, around different needs, and you mentioned older populations, and that's definitely one. When my conversations with Stu Phillips, and I had Theo Espoglu on from Leeds Beckett over in the UK, and talking about age-related sarcopenia and this anabolic resistance that takes place as people get older. Can you talk a little bit about that and about how protein needs might change as we get older? Yeah.
The study we're talking about right now actually is probably, I don't want to pump my own tires here, but it's the biggest analysis on anabolic resistance in healthy people, older people. And you can see there in one of the figures, it's a meta-regression. It's called a bubble plot. But the point is that older individuals are less responsive to a given protein dose. That's what anabolic resistance is. That's what Stu and Theo would have told you. So the hypothesis is, and what we're saying is that maybe we can overcome that resistance to protein if we just flood the system, if we just give more. And there's some really neat evidence coming out to suggest that that's correct. So, for the per dose recommendation right now in athlete populations is 0.25 grams of protein per kilo per meal. For older individuals, it's actually going to shift up to about 0.4 grams of protein per kilo per meal. And then, to give you something a bit more concrete, that's about 25 grams for like a young healthy man, and about 35 grams for an older individual. Older could mean anywhere 60 plus, depends on your definition of older.
Yeah, no, for sure. We get into some semantics there for sure, but I appreciate that in terms of them requiring greater amounts. And I work a lot in men's health. It's definitely something that, your guys' work I've been preaching to clients. And, as men and women get, let's say, into their 70s, things like appetite tends to come down. Something Theo talked about even in terms of, things that we might not think about normally, but even dentition, biting into a steak or something like that as you get older might not be as easy as it once was. And so getting to that 35 gram dose, can almost be challenging in that aspect. And I know there's some work going on around various supplements. I don't know if you can comment around, what might be coming out in the research or strategies around trying to achieve those intakes with older individuals.
Yeah, well, I could mention, that this is definitely an area of intense research, because we lose muscle as we age, and when we lose muscle, that brings with it a ton of comorbidities. Quality of life is a big one, but there's also the big hitters like cardiovascular disease and stroke that are all associated. Diabetes is perhaps a more obvious one with glucose uptake, but we need muscle. So strategies to offset that include maybe trying to find ways to protein's very satiating. So is there a way, like Theo would know all about this, is there a way to, like, maybe a liquid diet could help them get more? Maybe if I figure out that one amino acid is particularly anabolic, a big one floating around right now is leucine. Maybe if I could pack a bunch of leucine into a gummy, a shake, a bar, or something, maybe that could not suppress the appetite as much, but maybe give them the anabolic benefit of amino acids. So yeah, I can comment and say that it's definitely an intense area of research. We were talking about Tyler before the podcast started too, and Churchward Vinay would know more about that than most. So his research is all about, or has been about, different protein sources, insects, now whey protein, soy protein, BCAAs, leucine, etc. So definitely an area of interest anyway.
Yeah, I mean it's fascinating around the aging question, and you touched on obviously the different types of protein, and Tyler's great work. And I also had Dr. Cody Hahn on last season. He was talking all around the soy protein and a lot of the myths around soy protein that still sort of float around testosterone, things like that. I don't know if you want to comment or share your thoughts on the different types of proteins, or any suggestions to athletes or practitioners who are prescribing in terms of the types of proteins that people might be taking in.
Yeah, well, one of the most level-headed people I've ever talked to about this with is Tyler. And, there are ethical, moral reasons why people prefer vegetable proteins. And, that I tip the hat. There's no benefit to discourage that. However, there is some research to say that animal-sourced proteins are a bit more anabolic. Yeah, I suppose that's all I have to say. I mean, the benefits you get, like if you look at the meta-analyses that we're talking about here, the protein source didn't matter. So whey protein, soy protein, equally as effective. When I say animal source proteins may be a bit more anabolic, that's measuring very sensitive and acute turnover rates of proteins inside muscle. But whether or not that extrapolates in the long term doesn't look like it. And the benefit you get from the protein supplementation period, as we said in the beginning, is it's minimal. So I mean, in my opinion, you're splitting hairs. And if someone prefers soy protein, let them take soy protein, in my mind. If someone prefers whey protein because they're convinced it's got more leucine and it's more anabolic, then absolutely fine too. Anyway, those are my thoughts on it.
Yeah, it's tremendous. It comes down to that idea of compliance again, doesn't it? Like so many things of the thing the person's willing to do and is most consistent with, and being able to achieve it seems to always come out as some of the best strategies, right? So that's a great tip there. And Rob, if we circle back to your study in terms of, you'd mentioned previously again this idea of discrepancies with previous results from meta-analyses, and of course yourselves running the largest, which is impressive in terms of the largest meta-analyses ever done. And what were some of the reasons for some of those discrepancies previously, and with this additional evidence, are you able to then make more concrete statements now with all this added information?
The main differences between our meta-analysis and the other ones, definitely bigger, at least double in size compared to the second biggest. We included a bunch of other analyses, the meta-regressions that I mentioned, the daily protein intake biphasic regression that I mentioned. But the reason why we found protein supplementation was effective and many others didn't was the inclusion criteria. So some people included only older people who may be less responsive to protein, like we were talking about. Other meta-analyses, compared whey versus soy. Other meta-analyses were frankly not very comprehensive, so there was quite a few studies missed. Some studies were in hospitalized or unhealthy people. I saw another meta-analysis, I didn't cite it, but it included both human and animal research, which didn't make a ton of sense to me. Those are the overarching theme is that very different inclusion criteria. So we were only interested, or in this meta-analysis, were healthy people of all ages. It needed to be longer durations, so at least 6 weeks. That was our cutoff. If the study was less than 6 weeks, we didn't look at it. No animal work, and it had to include both a protein supplemented group and a non-supplemented group, but they had to be doing the same training protocol. And that, you'd think that that's an obvious thing to consider, but not all studies or meta-analyses considered that. So that's the main difference, anyway.
Terrific, and obviously, massive amount of work's gone into this. It's important findings and findings that are definitely can really transfer to practice so well. And for yourself, Rob, in terms of the evolution of this type of research, what are some of the next questions that you're trying to answer on the protein front that are, whether those are being applied to sport or in other areas?
Yeah, well, so far I think we've been relatively macroscopic in our scope here. We're talking about protein, which can be composed of a number of different amino acids, and it can be co-ingested and ingested with a number of other micronutrients. So I really think that the frontiers of nutrition research, anyway, is going to be pushing towards co-ingesting with carbohydrates. Is old. That's largely ineffective for protein synthesis, anyway. But vitamin D, calcium, creatine, maybe preferentially infusing other amino acids like leucine, for example, is a big one. I think that's the next step, and a persistent debate that I'm sure that you've fielded plenty more than most is whole food versus supplements. Mm-hmm. And there's going to be some pretty neat research coming out in those, as well as other. Like I can tell you at Mac, we're looking at different protein sources all the time: collagen, potato, whey, insect protein. I think Tyler's getting into now. That's really neat because a lot of other we're in a developed both of us right now are in developed countries where we don't have too much problem about finding protein, but other individuals may rely on wheat sources of protein or insect sources of protein. So there's a global perspective on this too.
Yeah, the crickets are going to be the next whey protein, right? Maybe. Yeah, it's interesting, isn't it, in terms of the different types and of course, answering all these questions. And when you look at some of these, we still hear a lot of the myths that persist around things like protein, and even in the medical field. And the one that tends to persist the most is always around protein intake and kidney health. And I'm sure you've flogged this, beaten this dead horse a little bit already, but for our listeners, can you talk a little bit about protein intake and kidney health and any potential concerns that anyone might have?
Yeah, so I was just talking to my friend who's he's neck deep in med school right now, and he was just taught that high protein diets cause kidney damage. And it's true that our kidneys are responsible for filtering our amino acids and ultimately excreting the amine backbone, the nitrogen. And so that's true. We need our kidneys to filter protein. But there's this circular logic that's existed that when someone has kidney failure and you give them protein, their kidney failure, and in fact, a number of outcomes get much worse. So it's circular because, okay, I had kidney damage, I gave high protein diets, and it got worse. So high protein diets caused kidney failure. And that's circular logic. So we've fought that quite a bit. There's no evidence, legitimately no evidence, that high protein diets inhibit or damage kidneys. And there's a number of outcomes you can look at. Glomerular filtration rate is probably the most clinical one. We just published a meta-analysis last year. The first author is Michaela DeVries. She's a prof at Waterloo in Ontario, and she knows a ton about it. She was the first author on that paper, but summarizing, it was at least 10 studies. There's no negative effect of high protein diets on kidney function as assessed by GFR, glomerular filtration rate. Yeah,
it's refreshing to hear, and it's amazing. Obviously, if Prof. Stu has mentioned that in the podcast, and Dr. Jose Antonio, and then Theo as well, and now yourself. And I think it's important for practitioners and docs listening in to continue to hear that, because that myth still really persists, and that idea of it stressing the kidneys is another phrase that's often used, and it's obviously not evidence-based. So thanks for continuing to shed some light on that. And
it's getting in the textbooks now, and it'll probably get filtered down to actual practitioners in a couple of years. That's just the way she goes. But yeah, there's no reason to hesitate from high protein diets from a kidney perspective, anyways.
Terrific. And from a practical sense here, Rob, if you're working with an athlete or an active person, what kind of advice would you then give them in terms of protein intake if you were trying to keep it, somewhat succinct for them to be able to achieve?
Yeah, so there'd be two considerations. One, are they trying to gain weight, or one, are they trying to lose weight? Broad sweeping, protein, in my opinion, is the macronutrient that I would consider being particular about more than fats and carbohydrates. So during periods of weight loss, I think that we would benefit from even higher protein intakes. And there's a nice systematic review by Eric Helms on that. Mm-hmm. Stu's led a paper on that where up to over 2.2 grams of protein per kilo, people were actually able to hold on their muscle during periods of weight loss. So if I was working with an athlete who's trying to cut weight, that'd be a pretty important consideration. I don't want them to lose part of their muscle as part of the weight loss process. So high protein diet is key for them. If someone's trying to gain weight, they probably don't need as much protein. That's perhaps more, it depends on what they're looking for, but the total calories matter, and fats are much more calorie dense, so that I would hesitate from excessive protein intakes, and shift them more towards maybe a higher fat diet as well.
Terrific. And on the general population side of things, when you look at unfortunately 2/3 of the population now are overweight or obese. We have a growing percentage of the population pre-diabetic, diabetic, hypertensive, as you mentioned, things like heart disease on the rise, cardiovascular disease, obviously the number one killer. What types of general recommendations for a coach or practitioner listening in a trainer who's working with this population, or somebody who's listening on that front, that could be a nice, general heuristic or tip for them?
Yeah, from a health perspective, there's massive epidemiology studies, and some neat ones now that are in all sorts of different countries, from developed to developing to third world. And higher carbohydrate diets are predispose you to all sorts of different risk factors. So from a health perspective, if I were to decrease anything, it would be carbohydrates. And if I were to increase anything, it'd be protein. That'd be a very succinct recommendation. Now for athletes, they do use more of glycogen, their glycogen stores, which come from carbohydrates in most. And they need to replenish what they use if they're doing successive training bouts or tournaments or whatever. It's a long-winded way to say that I think carbohydrates, the recommendation for carbohydrates is different in athlete populations because they're using their fuel so often that I would say, a simple, it could be like a 35 or a 40, 30, 30, or something like that. 40% carbohydrate, 30% fat, 30% protein would work very well for them. But from a general health, I would say drop the carbohydrate to maybe 20, 40, 40, for example.
Yeah, that's definitely one that I had a chance to hear Andy Jones give a talk around his work with Eliud Kipchoge and the Breaking Two, and how he had a colleague of his who was an elite recreational runner, marathoner. And when they were doing these tests, he got up to 16, 17 kilometers an hour and tapped out and couldn't keep going on the exercise test. And of course, they bring in the elites, and that's the speed they start the testing at. It's just
which is freaky. Yeah.
Which is freaky. I mean, it's like a totally different person, human, really. And so just as you mentioned there, in athletes, obviously that carbohydrate need being so much different than even recreational athletes, and again, even more so than our sedentary population. So, great point there. And I think, Rob, people are probably wondering by now, after all this protein talk, besides getting a little bit hungry, is, what's your protein intake like? What do you aim for per day, and how do you break that down between food and supplements?
Yeah, well, I still play a ton of sports, and I still lift weights 3 times a week. So after both sports and training sessions, I have a protein bar or protein shake. I'm quite particular about my protein intake. I've actually just this week I stopped tracking it, but I've used MyFitnessPal almost religiously, and I'm up where about 40% of my daily caloric intake comes from protein, and I try to distribute it relatively evenly throughout the day. And I try to practice what I preach. I try to drop my carbohydrates if I drop anything. But just carbohydrates and everything. So it's easier said than done, but
yeah, for sure.
Yeah, that's what I do anyway.
And would you be up more towards would you at the 1.6 or perhaps more towards the 2 or 2.2 grams per kilo then? Yeah,
I'm about 2, almost on the dot. I'm at 2. And it's the same rationale that I think anyone who would take it relatively serious would have and it's that I might as well overshoot than undershoot. So, and honestly, I quite enjoy my protein, my eggs,
nice,
whatever. So, yeah,
absolutely. Well, listen, I totally agree. I mean, in terms of being that quote unquote most important macronutrient and really prioritizing that. And as a lot of practitioners would say, kind of setting that protein intake so it just becomes second nature and you're always getting that right dose is so crucial. And, again, Rob, on this, protein front, obviously all your tremendous work, what's the next step for you in terms of your evolution as a researcher, and what are you up to next?
Yeah, well, I think my the thing I'm most passionate about is understanding the regulation of muscle mass. And that came from an athlete background and then working in athletics. But now I'm kind of shifting a bit more clinical. And I'm going to be doing some more, it's called bioinformatics, but it's big population and genome data, trying to understand what factors regulate the size of muscle. And, if someone has more hormones, more of testosterone, more of this, more of that, do they have more muscle? If someone has this SNP or this sequence of their genome versus another allele, do they have a higher propensity to increase muscle size with exercise? So those are the questions that I'm most interested in now. So I'm actually kind of shifting away from nutrition, but I'm staying within the house of muscle. And I'm trying to understand why some people can gain more muscle or have more muscle than others. And on the flip side of that, why do we lose muscle as we age? Why do we lose muscle when we stop using it? What is it about those things that cause us to become anabolically resistant, et cetera, et cetera? So I'm shifting a bit more clinical in my interests, but my background at least is very applied sports science.
That's tremendous. I mean, definitely on the health front, it's obviously so crucial and important, as you've highlighted in this episode. And I think even on the training front, a lot of coaches, practitioners, athletes listening in are always wondering, there's those individuals who can sort of look at a barbell and gain muscle mass, whereas others really need to put the training volume in and pack the food down to achieve it. So it'll be fascinating to see what you uncover in some of that research coming up.
Yeah, thank you.
And of course, big question here, Rob. You're finishing up your PhD. What's the celebration at the end here? What are you going to reward yourself with after all those hard years at work?
You know what? I just got into scuba diving. And I'm obsessed with it. So I think I'm going to go to Belize, and I'm going to go scuba diving. Yeah, for just a week of me and my girlfriend will probably just do a bunch of scuba.
Oh, fantastic. The Blue Hole, Belize, man. Have a great time.
That's it, yeah.
I appreciate you carving out some time, man. This is fantastic. Where can people stay connected with you and keep up with all this phenomenal research you're doing?
I think I'm pretty easy to find. I mean, I'm on Twitter. I'm on Instagram. I'm on Facebook. You can add me on Facebook. Research-wise, you can find me on PubMed. My middle name is William, so it's Morton RW, Google Scholar. I'm not as active on social media as some of the other guys that you mentioned, but that's just my style. But
too busy getting the work done.
No, it's just I tend to be a bit more reserved with social media, but you can find me on there. So please feel free to give me a follow.
Amazing. Well, listen, it was a real treat to have you on. I appreciate you coming on and sharing your insights, and hopefully I look forward to twisting your arm in the future and getting you back on.
I appreciate the opportunity. It was a pleasure.
Thank you for listening to the Dr. Bubbs Performance Podcast.